Okay, in this video we want to work some problems from the text on parallelogram properties. So let's look at number 7. But basically they're talking about the space between the hinges being the same and the angles being the same if it's a parallelogram, and they want us to verify. So find the values of x and y, so that it forms a parallelogram. So we want to show that these opposite angles are congruent to each other, because if it's a parallelogram, the opposite angles have to be congruent. So we want to find the x that makes these two angles equal. We can do 3x minus 4 equals 2x plus 16. Add 4 to both sides, take away 2, x equals 20. That gives 56 and 56. So those two angles are congruent, 56 degrees each. We want to do the same thing for these other opposite angles here. Set the y is equal. 2y plus 34 equals 4y minus 56. Take away 34 from both sides, we get minus 90. Take away 4x from both sides, we get minus 2x. Minus 2x, this is minus 90. Divide both sides by minus 2, x is 45. Now if x is 45, or y is 45 rather. If y is 45, we have 180, take away 56, which is 124. And up here we have 90 plus 34, which also is 124. So these also match. So yes, it is a parallelogram. Let's look at number 9. If we have parallelogram, diagonals are going to bisect each other, which means that the diagonals cut each other into congruent segments. So I want to set 3y minus 5 equal to 2y plus 18 and find the y that makes these equal, because that would be the midpoint. So take away 2y and add 5 to both sides, we get y equals 23. So if y is 23, 3 times 23 is 69. 69 take away 5 is 64. And 46 plus 18 is also 64. So these two are congruent to each other if y is 23. We want to do the same thing for the x's. So minus 4x minus 2 equals minus 3x plus 4. And we want to add 3x to both sides and add 2 to both sides. Add 3x to both sides, we get minus x. Add 2 to both sides, we get 6. Double check this, we got negatives involved here. Add 3x, we got negative x. Add 2, we got 6. So we got negative x equals 6, x equals negative 6. Now if x is negative 6, negative 4 times negative 6 is 24. 24 take away 2 is 22. And negative 3 times negative 6 is 18. 18 plus 4 also is 22. So even though 6 is negative, which is kind of unexpected, it works out and we get congruent segments. Let's look at number 10. Number 10, we want to show that opposite angles are congruent, because if it's a parallelogram, opposite angles have to be congruent. So we're going to set 5x plus 29 equal to 7x minus 11. Okay, take away 29 from both sides, we have minus 40. Take away 7x from both sides, we have minus 2x's. Divided by negative 2, x equals 20. Now if x is 20, we get 129. And we get 140 take away 11, which is 129. So we get equal angles there with x is equal to 20. Now we need the same thing for the other angles. 3y plus 15 equals 5y minus 9. Take 5y away from both sides, we get minus 2y's. Take 15 away from both sides, we get minus 24. Divided by negative 2, y equals 12. So now if y is 12, we got 36, 46, 51. And we have 60 take away 9, which is also 51. So we do get opposite angles. Either way we go there. Let's look at number 11. Determine whether ABCD is a parallelogram and justify your answer. So we could go for opposite sides being congruent, show that the distance from A to D is equal to the distance from B to C. And we haven't really done a distance formula one for a while, so let's do a distance formula problem. Let me blow this up a little bit to get more room in here. So we're going to work it over in this spot here. We want to do the distance from A to D, and so that's the same as the distance from B to C. So the distance from A to B is going to be the difference of the x's squared plus the difference of the y squared, and we take the square root. So from A to D, rather, we're doing AD first. A to D, this distance is going to be the difference of the x's, which is 1 squared, plus the difference of the y squared, which is 3 squared. So this is square root of 10. And the distance from B to C is going to be the difference of the x's in B and C. So if we look at B and C, this is also a difference of 1 for the x's, and it's going to be squared. So we got square root of 1 squared. And then if we look at the difference from B to C, that's going to also be 3 squared, which is root 10. So those two distances are the same. Those are congruent. Now, if we can show that AB, we got some choices. If we show AB and DC are congruent to each other, then we have a parallelogram because we have pairs of opposite congruent sides. Or if we could show that AD and BC are parallel and congruent at the same time, that would be enough for this to be a parallelogram. But I want to do the distance formula for A and B now. So I'm going to basically go for like all this opposite sides being congruent. So we want to do the distance formula with A and B. So A and B, the x's difference, 1, 2, 3, 4, 5, square root of 5 squared. And then looking at the y's are 1 apart. It's a 1 squared. This gives us root 26. And now if the distance from D to C comes out to be root 26, then we know we have a parallelogram because we have all opposite pairs of congruent sides. So let's look at D to C. 1, 2, 3, 4, 5. It's 5 squared for that part. And we got a negative 1 for this part. Negative 1 squared is still 1. You get root 26. So by using the distance formula, we've shown that both pairs of opposite sides are congruent. So yes, it is a parallelogram. Okay, for number 12, they want us to use the slope formula. So I've done these on another page so we can graph them out. So here's number 12. I plotted these out. And wants to use the slope formula or use the slope to show that this is a parallelogram. So we want to look at the slope from Q to P. And we want to look at from the slope of S to Y. And if these are the same, then these lines are parallel. So Q to P, the slope, the change in Y. Remember, slope is change in Y over change in X. The change in Y from Q to P is, if I go from Q to P, is 4 and over 3, or 4/3. The slope from S to Y is negative 4 if I go from Y to S over negative 3, which is the same thing as 4/3. So QP and SY are parallel to each other. Now if I can show that QS and PY are also parallel, we have a parallelogram. So we want to find the slope of QS. Let me move this up a little bit. And we want to find the slope of PY. So QS is pretty much has a 0 slope. If we look at the difference in the y's, we have no change in the y's. And the difference of the x's is 1, 2, 3, 4. We have 0 over 4, which is a 0 slope, horizontal line. And the same thing for the y's. We have 1, 2, 3, 4 for the x and 0 for the y. So these are also parallel since they have the same slope. So yes, both pairs of opposite sides congruent, or both pairs of opposite sides parallel. Okay, let's look at number 13. Number 13 wants us to use slope and distance. So I'm taking this that they want us to show that one pair of sides are both parallel and congruent. So let's do SR and CT. So we want to find the slope of SR, and we want to find the slope of ZT, and we also need to know that they're the same length. So we want to find the distance from S to R, and we want to find the distance from Z to T. So if we can show that we have one side that's both parallel and congruent, we have a parallelogram. So the slope from S to R, change in Y is 2, change in X is 1, 2, 3, we get 2/3. The slope of ZT, change in Y, 1, 2, change in X, 1, 2, 3, 2/3. So these are parallel to each other. Now we need to see if they're the same length. The distance from S to R, we're going to be doing the difference of the y's and the difference of the x's squared. So the x distance squared is 1, 2, 3 squared. And we want to take the square root of 3 squared. And then we want to take the difference of the y squared, which is 2 squared. So we get 9 and 4, which is square root of 13. Now if ZT comes out to be root 13, then we can say we have a parallelogram because we'll have parallel and congruent with one set of sides. From Z to T, difference of the y's, or difference of the x's first, 1, 2, 3, 3 squared. And the difference of the y's, 1, 2, 2 squared, also gives us root 13. So SR is congruent with ZT by the distances, and SR is also parallel with ZT by the slopes. So yes, it is a parallelogram. And this is because both opposite and both congruent and parallel. One side. So one side is both congruent and parallel. Okay, if we look at 14, it's obviously not a parallelogram. And if we look at 15, it's obviously not a parallelogram. So we won't bother with those. I'm not so sure about what they want us to do with midpoint anyway on this one. What I thought about one thing to do for midpoint would be to maybe come up with an equation for these two lines and show that they cross there and then that this distance and this distance was congruent. That would be kind of involved. The other thing we could do is use W and Y and find the midpoint. And then we could also find N and R and find the midpoint. But still, and those midpoints should be the same if it was a parallelogram, but we can see it's not a parallelogram. Okay, let's go back to the other page then to finish up. So we did those on the other page now. Now let's look down here at 27. So here, when a coordinate plane is drawn, placed over the map, the four streetlights are shown. Do they form the vertices of a parallelogram? Let's connect them together and see what they look like. And let's see. Justify your reasoning, explain any assumptions you make. Okay, so let's look at the slopes. Change in y, change in x. Let's call this A, B, C, D. So it looks like if we find the slope of AB and we find the slope of DC and we find the slope of AD and we find the slope of BC, if all of those opposite slopes are congruent, we have a parallelogram. So slope of AB, we look at the difference of the y's, 1, 2, 3. Difference of the x's, 1, 2, 3, 4, 5, 6. That gives us a 1/2. Going from D to C, we're going 1, 2, 3 for the y's. And we're going 1, 2, 3, 4, 5, 6 for the x's. That's also 1/2. So AB and DC are parallel to each other. Now let's do the same thing for AD. AD, if we look at the y's, 1, 2, 3, 4, 5, 6, 7, 8, difference of 9. Difference of the x's is back 1. So we have 9 over -1, which is a -9 slope. And from B to C, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 for the y's. And we're back 1, 2 for the x's. Make sure I counted that one right. 1, 2. I count this other one, that's also a -2. So this is a -9/2 slope. And this one here is also -9/2. So almost goofed on that one. But since they have the same slope, these are also parallel to each other, which gives us a parallelogram. And that's because both pairs of opposite sides are parallel.